Welcome to Predicting Energy Consumption for Power Systems Planning. I'm John Moose, presenting with Corbett Carell. Why forecast energy consumption? Well, it depends on your application. Long-term trends are generally looked at when installing transmission lines or generators to ensure that load can be met in the years and decades to come. Additionally, forecasts are used to figure out what will be the demand tomorrow and how do we meet that demand. While I've presented two applications here, there's a spectrum of uses for energy forecasting. What influences energy consumption? Well, there's a few trends we might look at. First, short-term trends, such as what day of the week is it? Seasonal trends, such as weather or appliance usage, or even economic or population growth, which are longer-term trends. The goal of this project was to use 2.5 years of historical weather, economic, and population data to predict energy consumption for the California Independent System Operator. We used two machine learning approaches, a linear regression model and a multi-layer perceptron regression model. 3 online APIs were used to collect all the data we needed for this project and pull them into a single Pandas data frame. We collected data from July 2015 through December 2018, and we set all of the data to a daily time resolution. In all, we had about 30 variables initially. We looked at 2 ways to reduce dimensions in our dataset. First, empirical deduction, we looked for variables that were highly correlated with each other and thus redundant. Secondly, we looked for variables that weren't well correlated with energy consumption. Secondly, we looked at principal component analysis, a method that seeks to maximize the variance between the dimensions in the dataset. However, we found some problems. We found that PCA didn't describe a large percentage of the variance, even when integrating a high number of principal components. Therefore, we decided not to implement this in our final presentation. This graph shows the results of the predictions from our 2 models. We can see a couple trends. First, in the spring and fall, our models tend to overpredict energy consumption, but the opposite happens during the warmer months where energy consumption spikes. Looking at the errors, we can see that both of our models stay within about a 20% range of overprediction and about a 12% range of underprediction. Overall, we found that the neural network showed about a 6.36% reduction in root mean squared error. However, the linear regression was much more straightforward to implement. Thank you.